The monitor view, let's take a deeper dive into the protocol profile and its role in feature extraction on the biosignal. Okay, so let's sign in as Demo 1. Let's go to the cog and bring up the monitor view. And let's hide the video display. Quick recap. Referential SPUs, there are 4 of them. Differential SPUs, there are 6 of them. The active ones are shown in green. And we're showing the 2 active ones here. They're indicated as active because they're actually controlling feedback presentation. Volume here, chime here, size here, chime there. The protocol profile is the black line along here. In the frequency domain, 0 to 64 Hertz, it indicates positive deviations frequencies there contribute to rewards, and negative deviations contribute to inhibits. Okay, we're first going to talk about the modes that can be applied to the spectrum. To date, we've been talking about the magnitude of the spectra. Let's recap that biosignal.network uses 1 Hertz bins. So when we say 64 Hertz, we're saying there are 64 bins across here collecting the energy at the respective frequencies. That's magnitude. There are other choices like sync, co-spectrum, and quad spectrum. To explain that more, let's pick a different protocol. Let's choose alpha lateral coherence. Alpha lateral coherence. Lateral implies left-right, and in fact it will present itself in the differential SPU. The protocol will have programmed it thus. So this represents the frequency domain of channel 1, frequency domain of channel 2. This is showing coherence, and it's a differential SPU, so it's in fact channel 1 minus channel 2, and the coherence at different frequencies. We can see there's spiking in coherence, and indeed when those spikes in coherence coincide with the band that's being rewarded, then rewards will be generated. We'll wait for one to occur. Thus, that would be, and we saw there it went green. That was a reward being generated. And similarly, if there's a spike in coherence in the inhibit bands here and here, then an inhibit will be generated. Let's talk about thresholds. These green lines up here. When the signal exceeds the threshold, well, that is the signal to in fact generate a digital reward, a logic reward, or inhibit, indeed. Green for reward, red for inhibit. They're actually overlaid in each at the moment, so we can only see one because the smoothing filters are the same for both. These are reward smoothing filters, inhibit smoothing filters. Let's change this one. And let's make this one really short by cycling it through 32 and back down to, let's say, 1 second. And let's do a reset on the thresholding and let it grow. We'll see that because that's a fast time constant of 1 second, the red is growing, the red threshold level is growing, as is the reward threshold. This is saying it wants to generate an inhibit every 1 second. So in fact, the threshold is lower. And it's easier for the real-time signal to exceed the threshold because it wants to generate an inhibit, which is flashing here in red, every 1 second. The duration is 1/4 of a second. Here, it only wants to generate a reward every 16 seconds, and therefore the threshold is higher, and rarely does the real-time signal exceed that green threshold. So we rarely see that reward threshold being exceeded. If we change this back to something fast, then we'll see that the green threshold is adjusting itself in real time, diminishing. And in fact, now we're getting those rewards generated quite frequently. It's in fact trying to generate one every half a second. That's the target. So that's coherence. It's comparing it frequency by frequency, the coherence between channel 1 and channel 2, and it's represented in this graph here, and it's set by the coherence. In fact, there are a lot of functions, many functions. Co-spectrum, quad spectrum, phase, synchrony, synchrony co-spectrum, synchrony quad spectrum, power differential, the power difference between frequencies in channel 1 and channel 2. So that's why it's going above and below zero. The summation of the powers in channel 1 and channel 2. All of those functions, and the complex differential, the complex subtraction of the powers in channel 1 and channel 2, and the complex addition. So there's about 10 different functions that are applied to the FFT. Having chosen the one you want, when you save that, that will be saved. That modality of the FFT will be saved, and when you recall that protocol, it will recall that modality. Okay, a lot to take in. Next video, we'll look at the media matrix.